Okay, so today we are at lesson 1.9, still working with quadratic equations, but today we're going to look at these quadratic equations written in factored form. Okay, so this is more like an introduction. Our learning objective: students will understand quadratic equations can be written in factored form. Okay? Okay, so we're going to first start with a little warm-up just to see what we remember from past videos. So I'm going to give you guys a brief moment to kind of take a look at that and to input your answers here. Okay, so the first question is asking us the vertex. So of course I have this quadratic equation that is written in vertex form, and I want to know what the vertex is. Alright, so my vertex for this equation should be -6, 7. My a value should be -1. And how does that, and my h value should be -6. And my k value should be -7. Now, let's go back to the a value. How does that a value being -1, how does that affect the parabola? Well, it causes the parabola to either, you can say, reflect or to flip down or something of that nature. The h value causes the parabola to either move left or right. In this case, it causes it to move left because that h value is a +6, or it is a +6, but technically it's the opposite, so we say the h value is -6. And then the k value here and causes the parabola to either move up and down. And in this case, since that k, it is going to cause that parabola to move down 7 spaces. Okay, so it's a great way to attack some stuff that we did before. So let's move on in this lesson. Okay, over the past couple of days, we have looked at quadratic equations that are written in standard form. Okay, we have looked at quadratic equations that are written in vertex form. Today we're going to take a look at quadratic equations that are written in factored form. Okay, and so these quadratic equations that are written in factored form, and as you can see, I have a here highlighted and I have c here highlighted. And of course, you know that there is going to be some values that's going to go into these spots here. All right, but we know normally we always say that a cannot equal 0. But this time it says that a and c could be any number, even 0. Well, let's see what we're talking about. Let's see what happens, because normally we notice that when a was 0, then the equation was no longer quadratic. Okay, so let's see what happens. Alright, so if I have this equation here, and as you can see, I have a value substituted in for a, and I also have a value substituted in for c. Now, if I look closely, I can tell these look very familiar, right? It almost look like two polynomials that I was used to seeing, right? Two binomials. So in my first group, I have one binomial. In my second group, I have another binomial. All right, so if I were to kind of try to simplify this and multiply it out, I would have to multiply my x by my x, which gives me x squared. Then I would have to multiply the x by the -5, and that's going to give me -5x. Then I would multiply -0 or just 0, because remember, 0 can't be negative or positive. Alright, but in this case, since there is a negative in front of the 0, let's just treat it as it is. Okay, so we're going to say -0 times x, which is going to give us a -0x. And then lastly, we have 0 times -5, which just causes it to be 0 as well. Alright, so this is what I have. Now, of course, like all the time, when we get this and we're simplifying, because all we did was multiply, we have to combine our like terms. And you can see that -5 and -0x are our like terms. So if we combine those together and simplify it, we should get this. Now, the key here to know that, wow, this factored form really is quadratic. And mostly it's because of these x's. When I multiplied those x's together, it gave me the degree that I needed in order to verify and say that, yeah, this is truly quadratic. All right, so here in this factored form, basically what we have are two polynomials that are just being multiplied with each other. And when things are being multiplied together, we call those things factors. Okay, so here we have one factor, which is made up of x minus a, and we have our second factor, which is x minus c. The reason they are factors is because they're being multiplied together with each other. All right, so in this case here, when we simplified here, we now know that this is quadratic. Okay, it is quadratic. Okay, I know that this says is no longer quadratic, but it actually is quadratic. Okay, so I had to go back in and spruce it up a little bit because we said that it wasn't, but actually, which means that the equation would be quadratic because of now it is of degree 2. And we've learned in previous videos and in previous lessons that anything that has a degree of 2 makes it quadratic to where it looks like a parabola if I were to graph it. Okay, so let's continue on this lesson. So let's see if we can graph some equations in factored form using Desmos. So as you can see, the equations below, and if you guys want to go and graph these in Desmos, you could pause the video or you could just stop at some time and go graph these equations yourself in Desmos just like this, okay? And see if this is what you come up with. Now, I highlighted something important. I didn't highlight the vertex, although we know that I could have highlighted the vertex once I graphed the equation in Desmos, but I mainly highlighted these x-intercepts here, okay? And I did that for a reason. All right, so let's look. This first factor up here, which is x minus 0, that's a factor. Notice that my x-intercept is 0. Wow. And this number here is 0. All right, let's see. If I notice here, my second factor is x minus 5, but this x-intercept, it crosses the x-axis at 5, but it's -5, it's -5. Very interesting. Okay, so if this is the case, maybe there's a connection to these x-intercepts. So I see that my values here in this factored form is 4 and 5. So would that mean that it will cross the x-axis somewhere at 5 and 4? Well, yeah, absolutely. But even though this is positive 5, this saying it crosses it at -5. This is positive 4, and this is -4. But the 4 kind of hints to something. And if we look here, this -2 correlates to this 2, and this positive 2 correlates to this -2. So I just feel like I just found something out, or I figured something out. And if you figured out the numbers inside the factors are just the x-intercepts, but we just take the opposite sign. Wow. So if this is -5, really my intercept would be at 5. If this is -4, really my intercept would be at 4. If this is 5, really my intercept would be at -5. And if this is -2, really my intercept would be at 2. And if this is positive 2, really my x-intercept would be at -2. Wow, it's just the opposite. All right, let's look at some different ways. Okay, so don't forget what we just discussed, but let's look at some different ways in which we can write the x-intercept, okay? Or what we sometimes use to call the x-intercept, because these are very important things that you need to know, especially when you're reading these problems. All right, so first, we also refer to x-intercepts as roots, okay? We sometimes of course, you guys know we call x-intercepts just what they are, x-intercepts. Okay, we sometimes call these x-intercepts solutions. Okay, it's another word. And sometimes we call these x-intercepts zeros. Okay, but the most important thing is, and the key is that they all mean x-intercept. They're all talking about where they cross the graph on the x-axis. All right, so let's move on. Let's take a look at some examples here to try to put into play what we just discussed. So given this example here, I see that I have this equation and it's written in factor form. I see that my two factors is x plus 2 and x minus 5. What I want you to see, or if I want you to tell me, what are the, sometimes I call them x-intercepts, sometimes I call them roots, sometimes I call them solutions, but they all mean x-intercepts. So can I find the x-intercept given this equation right here? And so looking at the equation, I should see that my x-intercept would be at -2, because this is positive 2 and a positive 5. Given this equation, I see that my x-intercept here is just 0, because remember, 0 cannot be negative or positive. Okay? And here, my x-intercept would be a positive 2 and a -7, so that's where it crosses the x-axis. And in this equation, my x-intercept would be at absolutely -8 and positive 10. All right, so great job with that. Now we're going to see if we can write equations in factor form, now given the graphs. All right, so let's look at the first graph here. Notice that I just have the graph, but I know what the x-intercepts are. So since I know what the x-intercepts are, can I write an equation in factor form? Yes. So the equation would be x plus 4 and x minus 6. Now, the thing is, why is it x plus 4 and x minus 6? Remember, the signs are always going to be the opposite. So since this is negative working backwards, this would actually be positive. Since this is positive working backwards, it would actually be negative. All right, let's try another one. So looking at this graph, what do you think my x-intercepts will be? If you said x minus 3 and x minus 9, you were absolutely correct. And lastly, looking at this one, do I have any x-intercepts? Yeah, some of you guys might have noticed also that the x-intercept is also our vertex. Can that happen? Absolutely. So in this case, I only have one x-intercept, okay? And what would that look like? I would just write it twice. And I see that that x-intercept is a positive 3, so it would definitely mean that it would be x minus 3 and x minus 3, okay, for my two factors, showing that they're going to be the opposite signs of whatever is inside. All right, so today we just came through and we looked at an introduction, just introducing you guys and getting you guys comfortable with just looking at the factored form of a quadratic equation. Tomorrow we're going to come back and we're going to look at how to now write these equations in factored form by doing a little bit of factoring. Okay, so we're going to talk a little bit more about factoring as we go on, and I will see you guys tomorrow.